Good evening, everyone. Welcome to the February meeting of the Popular Astronomy Club here in the Quad Cities. I'd like to welcome those of you who are here at Butterworth Center and those, I believe about 18 or so that we have attending online. I want to remind you, if you're attending online, please mute your microphone until we get to the question and answer period, so that we have a minimum background noise while the speaker is on. If you have a question, there will be a question and answer period at the end of the talk. If you have questions during the talk too, you can always put them in the Zoom chat box from online. Okay, for some reason, I'm not advancing. Oh, here it is. Okay. Tonight, we will, our featured presentation, as I said, follow by question and answer period. We'll talk about some of the upcoming events, and we'll have time for a few member observations yet tonight. Our featured presentation is showing on the main, okay. I'm not screening that off to the side. For tonight, we have Brother Guy Consolmagno to talk about discarded worlds, astronomical ideas that were almost correct. A little bit about Brother Consolmagno. A native of Detroit, Michigan, Brother Guy Consolmagno holds both BS and MS degrees in planetary science from MIT and a doctorate from planetary science from the University of Arizona. He also spent 2 years in the Peace Corps teaching physics and astronomy in Kenya, and he later became assistant professor at Lafayette College in Eastern Pennsylvania. His brother Guy also joined the Jesuit order in 1989 and was assigned to the Vatican Observatory in 1993. He's also the co-author of 2 astronomy books and co-author of 4 books exploring the issues of faith and science. He has published numerous articles in astronomical journals and publications, and writes a column for the Tablet, a monthly magazine covering international Catholicism. His astronomical research was focused on the connections between meteorites and asteroids and the origin and evolution of small bodies in the solar system. He was a member of a NSF team that went to Antarctica in 1996 to collect and analyze meteorites. Tonight, Brother Guy will look at the ways observers and astronomers such as Aristotle and Giovanni Schiaparelli came up with the ideas that were almost correct, but in fact were wrong. We will learn how the now discarded images of the universe posed in the past can provide lessons for today's astronomy. So I welcome you, Brother Consolmagno, to the Popular Astronomy Club, and I will turn off my sharing and we will proceed with your presentation.
Now, I hope you can see the presentation and also hear me.
Hear you. Yeah.
I'm delighted to be there. I only wish I could be there in person. I mentioned the Peace Corps. I did part of my training for the Peace Corps, not too far from the Quad Cities, in Mount Carroll, Illinois. And that was more years ago than I want to confess to. About 1983. What I'm talking about today are discarded worlds. And I have a shout out there to Chris Graney, an adjunct scholar at the Vatican Observatory with me, who's a historian of science. And in fact, Chris and I have, let's see if we can get my thing. There we go. We've got a new book just came out, When Science Goes Wrong. And it's a history of astronomy, and a lot of the stories I'm telling today can be found in this book. So if you want to chase it down, basically what I recommend if people want to find a book of mine, go to Amazon.com and find any book that's written by me and buy 2 copies, and then you'll be sure to get the one you want. And the title, The Discarded Image, actually comes from another book, one of my favorites by C.S. Lewis. Many of you know him as the guy who wrote the Narnia books, but he had a day job, which was teaching literature, medieval and Renaissance literature at Oxford and then at Cambridge. And in his lectures, which are put into this book, he goes on at great length about the wonderful cosmology, the wonderful picture of the universe that the medievals had. And as he says, there are few constructions of the imagination to have combined splendor, sobriety, and coherence to the same degree. There was only one problem with it. It wasn't true. That's not something to be ashamed of, because out of that, we were able to derive all sorts of fascinating things about how the universe does work. But it was not just the medievals who were faced with this problem. You mentioned Aryabhata. He was a great astronomer in India around the year 500. And he came up with the revolutionary idea, though he still had the Earth sort of in the center of the field of stars. He said maybe the rising and setting of stars was due to the fact that the Earth was spinning. He also had a tremendous amount of observational evidence, both his own and evidence that he had inherited from the Babylonians going back hundreds and hundreds of years, about 1,000 years at that point. And out of which he was able to compute, well, if the Earth is spinning and the stars are fixed, how long does it take for each of the planets to go through the stars? And he says in his writings that, for instance, Mercury, it takes 125 Earth years for Mercury to go through the stars 519 times. If you do the calculation, that comes out with a Mercury period of 0.240848 Earth years. And the period that we have now in our observations is 0.240839. Incredibly close. And he did this sort of ratioing for the periods of Venus and Mars and Jupiter and Saturn. The interesting thing is that his numbers, even for Jupiter, are good to 3 decimal places, and the closer in, the shorter the period, the higher the precision. The precision for Mars is good to almost 5 decimal places. Only trouble was they didn't have decimal places back in 500 AD. The only way you could express these numbers was as a ratio. So he assumed, because these numbers seemed to work to the precision that they could measure, he assumed that the periods actually were ratios, which is to say, rational numbers. We now know that they're irrational numbers. If they're rational numbers, you could multiply them all together and find the common denominator and find how long it takes for all of the planets, including the sun and the moon, to actually repeat themselves. And then he said, I now know what the period, the age of the universe is. Of course, the positions of the planets, they were all astrologers back then, must control what's going on on Earth. Therefore, everything on the Earth repeats itself with a period, turns out, of about 4.2 billion years, which isn't all that far from the actual current, estimate for the age of the solar system. The trouble was, he was a little bit wrong, because they're not perfect ratios. The planets actually don't repeat themselves. There was no way he could have known that with the mathematics of the time. It was brilliant astronomy, excellent mathematics. It was almost right. But the universe doesn't repeat itself that way. We do know, of course, of the Aristotelian view of the universe. It looks like the Earth is there at the center and each of the planets going out. The Earth is not at the center. The Earth is at the bottom of the universe, the dregs of the universe. And it's only when you go further and further out that things get better till you get to heaven at the farthest edges. But the other thing about this view of the universe is that it seemed to agree with a common sense idea of physics. At the bottom, where things fall, because until they can't fall any further, are all the rocky bits. And if you don't think that that's the bottom and the worst part of the universe, remember that the inferno, hell, is in the center of the rocky bits. So, if you thought being at the center was the best part of the universe, then you'd make hell even better than the earth. It's just the opposite. The rocks on the earth fall through everything and fall to the center of the universe. Water falls through the rest of the universe until it hits the rocks and it's on top of the rock. Air is then, of course, on top of the water. If you happen to have air inside the water, it bubbles out until it makes a layer around that. And the final era is fire. And if you don't believe that the universe is, covered with a ring of fire, take a look at the sky at sunset. You can see the fire, the red in the sky. This was simply describing what they saw in the universe. And indeed, the four elements they had were the four, phases of material that we talk about now. It was brilliant description. It kind of is an oversimplification, but it was a brilliant description of how the universe worked. And for a lot of reasons, people believe that, the stars and the planets are moving around this immovable Earth, because why would the Earth move? Now, there was a bishop writing in the year 1300 in a book about the sky and the Earth. And in this book, he goes, really, all motions are relative. If you had an arrow and you fired it to the east and then fired another one to the west, but it had the natural circular motion of the Earth spinning, then you wouldn't be able to tell any difference going one way or the other way. Reason alone cannot rule out the possibility that the Earth is spinning and the stars are standing still. A complete violation of the old Aristotelian idea, a very, very modern point of view. Why do I use this as an example of science going wrong? Because this next paragraph goes, of course, everybody knows that the heavens are moving and the earth is standing still. I know that too. I'm just showing you the limits of reason, which could not, bring you to this obvious fact that the earth is standing still. So close, but not quite. There is another point, however, that I think is important to remember. First of all, people knew the world was round even before Columbus. People say that Columbus proved the world was round. How did he do that? He didn't even make it around the world. That's a complete fallacy, a description of what Columbus was up to. What we have here is, first of all, the shadow of the Earth on the moon. You can see it's round. And below are three views of a globe that you can find in a museum in Germany that was made just a few decades before Columbus. And on this globe, you can see that the land is all on one side and the other side of the globe is all water, just like Columbus believed, because that was why he thought you could sail away from Spain, go as far as you could until you ran into land, and land would be at the other end of this dry land would be at the other end of the continent, back where India was. Why didn't anybody think that there might be another continent where the Americas were? It came from that Aristotelian view of the universe. There's a lot of earth. We know the earth is big. There's a lot of air. You can't reach to the top of the air. There's a lot of fire. So presumably, there would also be a lot of water. Which raises the question, why is it that the earth is not entirely covered with water? Why do we have any dry land at all? If the world is in this nice, logical sequence in equal amounts of fire and air and water and earth. The answer, they thought in the Middle Ages, could be found in Scripture. Go back to Genesis, where it reads, God said, let the waters that are under the heaven be gathered together in one place, and dry land appear. And so it was done. And God called the dry land earth, and the gathering together of the waters he called the seas. Now, when Genesis was written, this was about 100 years before the Aristotelian picture that we're talking about. But the people understanding Genesis and the Aristotelian picture thought that they could make sense of the one with the other. Here's what they thought. They thought that by the gathering of the waters, it really meant that the sphere of water was pulled to one side. The earth is still the center of the universe, but there was this large lump of water pulled to the side and the dry land above it. And of course, the center of the dry land would be the most important city in the universe, which would be Jerusalem. Now, this meant that if you wanted the earth to be spinning, it would be spinning kind of off kilter, and that didn't make any sense. But they didn't think the earth was spinning, so what's the problem there? Indeed, if you talk about boats going away, you'll see that the boats are actually sailing uphill once they sail far away from the dry land. That's why they're called the high seas. And the further you go, the deeper the water. Here's another thing. If you ever go to the ocean and you put up a telescope and you try to point it at the horizon and you see, is it exactly level? More often than not, you actually have to tilt the telescope up to see the horizon. Proof that the waters have been pulled back and the high seas are really high seas. Actually, it's due to the diffraction of light caused by the atmosphere, but they didn't know that back then. They thought that they had this beautiful picture of the earth with the water pulled to one side and the dry land in the other, and Jerusalem in the center of the dry land. You can see pictures of this. We're now talking pictures in the 1600s. This is, 150 years after Columbus, and people still thought this was the view of the universe. And in fact, this explained how you could have springs of water coming up higher than the water level. Indeed, as late as 1777, a book published in Scotland trying to come up with rational arguments to prove the existence of God writes, argument number 4, the being of the vast sea where there is such abundance of waters is something higher than the earth, which are yet bounded and restrained from overflowing and drowning the land and its inhabitants as once they did, shows that God must be holding the waters back. By 1777, they already knew the earth was a planet. They already knew that the earth was spinning, and people were still using this as a very fallacious proof of the existence of God. Hey, I'm a guy at the Vatican. I'm a Jesuit brother. I have no problem with people believing in God, right? Because I do. I do have problems with people thinking that science is so much better that God is dependent on whether or not science can prove his existence. I got some problems with that one. And you also notice that all of a sudden he's talking about the Noah's flood as being when God stopped restraining the oceans, which isn't even what, the story of Noah and the ark is talking about. He's so in love with his science that he's, hasn't bothered reading scripture for a while. People do that. Why do I put it as almost correct? Funny thing, if you do a mathematical mapping of all the dry land on Earth, including the Americas, the mathematical center of all the dry land is actually not all that far from Jerusalem. But never mind. Coincidences do happen. Speaking of coincidences, and the fact that I'm at the Vatican Observatory, about 100 years ago, the Vatican Library decided they wanted to clear some of their shelves by sending to us at the observatory all of the modern books of science. To them, modern means printed with a printing press. So we've got on our shelves this book by a fellow named Bode. And on page 635, in the footnote, he has this marvelous description of how you can work out the positions of the planets in a wonderful mathematical sequence. So you start with Mercury and you start with the number 4, which is 4/10 of an AU. You add 3 and you get 7, which is Venus. You add 4 plus 6, and you get where the Earth is. 6 being 3 plus 3. You double 6 and add 4 to that, and you've got the position where Mars is. You take 4 and add 12, and you get 24 rather, and you get 28, which is, they later discovered an asteroid series where there was none. This law allowed them to predict where a planet was going to be. It turns out Ceres isn't really a planet, but we won't go there. Do it again, 4 plus double 24 to 48, and you get where Jupiter is. 4 plus double 48 is 96, and you get where Saturn is. This was able to predict the astronomical positions in astronomical units of all the planets. Mere coincidence? I think not. Until, of course, they discovered Uranus, and Uranus works. My gosh, it really, really does work. Well, Neptune doesn't work. We'll ignore that and say, where would, is there a planet at astronomical distance of 38.8? Well, Pluto is close to there. Obviously, Pluto must be a planet because it fits Bode's law. It's a coincidence. There is no predictive value to this. Ceres is not a planet, it's a dwarf planet. Pluto is not a planet, it's a dwarf planet. There's a bunch of other dwarf planets out there that don't fit this law at all. Neptune doesn't fit this law at all. When you look carefully, Saturn actually doesn't fit the law either. For that matter, Mars really doesn't fit the law either. This is one of those laws that if you want to believe hard it works, you will blur up all the places where it isn't. I'm reminded of the fellow who wanted to say that all odd numbers were prime. And when somebody pointed out that 9 was an odd number and it wasn't prime, he said, oh, it's experimental error. It's a way of looking at the world and seeing regularities and determining that the regularities must be telling me something, when in fact, they're not as regular as you think. And in fact, it's coincidence. I learned my planetary science 50 years ago at MIT. And one of the things that we did to try to understand how planets were formed were to look at the regularities in our own solar system. One of the first regularities we noticed was that all of the planets are orbiting in the same plane, and that plane is near the equator of the sun, and they all go around the sun at the same rate. And I'm giving myself a cough drop here because I'm getting a little dry. It must be that the sun and the planets were all formed out of a disk of gas that flattened because centrifugal force held up the disk in one direction, but it collapsed at the top of the bottom. And it's all spinning, and all the planets were formed in this disk gas. And if we ever look for places where planets are formed, we should see disks like this. You know what? We do. If you look at now with the high-powered telescopes into the Orion Nebula, a lot of other star formation regions, you find the disks exactly like this theory predicted. Not bad. Another thing that you noticed is that all the rocky planets are close to the sun, and all the giant planets, which are made of gas or ice and gas, are far away from the sun. And I can explain this too. If you've got a cloud of gas and dust, with the sun being hot as it's forming in the center, the closer to the sun you are, the more heat you have. The more heat you have, the more that certain materials are going to be vaporized. Certainly, water vapor will be vaporized until you get far enough away from the proto-sun where suddenly hydrogen and oxygen, which forms water, will make ice instead of gaseous water. Now, oxygen is the third most abundant element in the universe, Hydrogen is the most abundant element. So there's a lot of water out there. As soon as you get to a region where water is stable as an ice rather than as gas, then literally you're going to make snow, which can snowball to form the core of a giant planet. And this is going to happen faster than inside the frost line because you've got 3 times more material. Higher odds that it's actually going to run into itself. If this happens while the solar nebula gas is still present, while the disk is still there before it's all collapsed into the sun, then these planets formed in the outer reaches are going to suddenly jump up in size because they're going to collect all of this gas and dust. That explains why the rocky planets are close to the sun. It explains why the gas giant planets are farther away from the sun. And it explains something else very interesting. It explains why there are no planets bigger than Earth, but smaller than Neptune. Because as soon as they come a little bit bigger than Earth, they start gathering all this gas and they leapfrog up to become a gas giant. Beautiful theory. Explains everything we saw in the solar system. It's almost right. Then we started finding planets around other stars. And the first ones we found were Jupiter's orbiting their star closer than Mercury is to our star. Well, those would be the easiest ones to find, so maybe it's just a selection effect, except we're finding an awful lot of them. Eventually, we found a system of measuring planets, including smaller planets, seeing as they transit in front of their star. And when you look at the somewhat 5,000 planets we've discovered so far, we discover a vast number of these red guys up there, the hot Jupiters, where there should be no planets. But the vast majority of planets that we've discovered orbiting other stars happen to sit in exactly that region between rocky planets and gas giant planets that my theory from 50 years ago, wasn't mine, says are going to be impossible. The theory that explained why there would be no planets in that region has to deal with the fact that, in fact, most planets are in that region, just not planets around our sun. The assumption that our solar system was typical turns out to be really, really wrong. It was a big thing to realize that the sun is a star, and that's true. But most stars are not like our sun. It was a big thing to realize that the Earth was a planet. That's absolutely true. But we have never seen a planet around any other star that really is like the Earth. In spite of all the hype that you're going to read every now and then, an Earth-like planet has been found. Those planets are not at all Earth-like. They're just less not Earth-like than all the other ones we see. We have to deal with the fact that the universe insists on being stranger than what we wanted it to be. When it comes to people who are almost correct, Schiaparelli, notice how I'm pronouncing it the Italian way. I had to learn that when I moved to Italy. Schiaparelli, the SCH is a hard SC in Italian. It's not German. Schiaparelli, did I say that enough times? One of the great astronomers of the 19th century, and he really was. He made some phenomenal observations. Unfortunately, he also made a few that don't hold up to the test of time. This is a map, actually, of Percival Lowell, based on what Schiaparelli was doing, of what they thought Mars was. And you could see the dark regions are actually not all that far off from what a telescope can see. But they also imagined all sorts of thin canals. Schiaparelli used the word canale, meaning channel. Percival Lowell misread the Italian and read it as canals. We now know it's an optical illusion. You can actually get a sense of lines coming out when you turn up on sharp masking, and you will see artifacts that look something like those canals, optical illusions. Schiaparelli was also the fellow who observed Mercury with enormous detail, and he thought he saw markings on Mercury. Based on the markings he saw, and the fact that the markings were always in the same relationship on Mercury when he observed, he wrote, this of course was Italian, but I think you can read immediately and without further calculation, the duration of rotation of Mercury is equal to that of one sidereal revolution, which is to say 87.9693 Earth days. And what's more, that, according to his observations, is good to 1 part in 1,000. Now, anybody in this room may remember from the science fiction stories we read as kids, Mercury always keeping its one face to the sun, but you also know that it's not true. He's wrong. How did he go wrong? Was he just imagining these things that didn't exist? It's worse than that. You guys have observed Mercury. You know when the best times to observe Mercury are. This is a table from an old edition of Turn Left at Orion, a book that I happen to like particularly. Take a look at the author someday. And you know that Mercury's orbit is elliptical, so you might think that the best time to observe Mercury is when it's farthest away from the sun. But you've got the ecliptic to deal with. In August, when the Mercury is far from the sun, the ecliptic is close to the horizon, so it's actually not very far up above the horizon. But in April, when Mercury is far from the sun, it's actually easier to see. It means that there are only certain times in the year when you can observe Mercury. You look at the times when Schiaparelli actually observed, it's in his book, and you work out the number of days between each observing period, and you find that it is an almost even multiple, and an even multiple, which is to say every 2 Mercury days, every 4 Mercury days, because with radar we now know that Mercury spins once every 59 days. But he's only observing it every interval of 2 times 59 days, which is to say he actually is seeing Mercury at the same orientation. It's like a stroboscope. It's like the wagon wheels that look on a movie that look like they're not moving, because the motion of the wagon wheels is perfectly timed with the frame rate of the movie. He actually did see Mercury, and he saw it beautifully, and he came to the obvious conclusion that it couldn't possibly be a coincidence of 59 days, but there it is. To my mind, though, the saddest thing about Schiaparelli, the worst mistake he made, was looking at meteors. As you know, meteors come in showers, and we can describe what the showers are by where the radiant appears to be. Here's my favorite H.A. Rey map, and underneath it is a photograph of the Leonids, and you will see why it's called the Leonids. They all seem to be radiating out from Leo the lion. This photograph came from a buddy of mine who was at one of our summer schools years ago. Schiaparelli understood what was going on. The Earth is plowing into an orbit, an ellipse of dust, and when it plows in, it happens to have Leo on the far side, and the rest of the time it doesn't see that dust. Knowing that the Leonids are especially bright every 33 years, that then gives them an from Kepler's law what the semi-major axis ought to be. From the angle of where the dust actually hits the Earth when it does hit, he was able to work out a perihelion district, an eccentricity, an inclination, and then he saw that that exactly matched the orbital period, semi-major axis, perihelion distance, eccentricity of Comet Tempel-Tuttle. He discovered that the Leonids are lying in the orbit of Comet Tempel-Tuttle. Phenomenal bit of research and mathematical calculation. What's almost correct about it? He then goes on to argue that this proves that comets are made from the accretion of clouds of dust. Because after all, gravity pulls things in. It never occurred to him that comets also are made of ice, which are evaporating and string the dust behind. He got all this far and got the last step exactly backwards. Almost correct. Now that I've made fun of all these brilliant scientists ahead of me, I'm going to tell a story on myself. Not that long ago, I was reading Harry Potter, and Hermione is correcting Harry's, astronomy homework. And she goes, Harry, the moons of Jupiter are not covered with mice. They're covered with ice. And I'm reading that, I'm going, that was my master's thesis at MIT. In fact, I was invited to be an author on a big book on Europa. One of the opening chapters talking about the research that I had done back in 1974 and 75 about the icy surface of a moon Europa. That was an early copy. I had changed the title of my master's thesis that I defended in 1975. That's what I looked like in 1975. Didn't have the beard. Had hair that I will kind of don't want to talk about anymore. The interesting thing about Europa, you see, is that it's got a density that tells you it's mostly rock, and yet it's completely covered with ice. And my master's thesis explained this, that the rock generated enough heat that the water would come to the surface and cover Europa with a thin crust of ice. I wrote this up, and then I was talking to my co-authors, where can I describe this? And they said, well, the chapter we're writing is actually the history chapter, because your theory in 1975, by 1995, was so obsolete that we include it only for historical perspective. Oh, well, they're kind of right, because it was 20 years old. And before we even went to Europa, before we had a spacecraft flying by it and seeing the icy surface, I had come up with this theory. And then I'm reading the rest of the history chapter. Part 1, Galileo discovers the icy moons. Part 2, young guy Consolmagno gets them, explains why there's ice on the surface. How did I know there was ice on the? How did anybody know that there was ice on the surface? I knew because my thesis advisor told me. How did he know? How do you know that the moons are covered with ice? How does Hermione Granger know that? There's actually 3 things that we use. Number 1, the idea that ice is really common in the solar system. I talked about that. Number 2, the fact that the albedo, the intrinsic brightness of Europa, is way brighter than a rocky body like the moon. The moon reflects 12% of the light that hits it. Europa reflects 64%. And the third thing we know is that the density of Europa is less dense than a purely rocky body. Okay. So who was the first person to put all of that together? Well, it had to be somebody who knew the density of these bodies and who knew the brightness of these bodies. When did people first work out the density of the moons of Jupiter? It was a guy named Laplace in 1803. He worked out the masses, not because of the way they orbit. A body in orbit is a falling body, and Galileo said, well, a light body and a heavy body are going to fall at the same rate. The orbits are going to be the same. But Laplace looked at how the 4 moons interacted with each other, and with some incredibly beautiful mathematics, worked out the masses. Now, he only worked out the masses with relation to the mass of Jupiter, but we know the mass of Jupiter because these moons are falling around it. And of course, to do the calculations, if you know your physics, you've got to know the value of big G, the gravitational constant. When was that measured? 1795, Cavendish did this. By 1803, They knew how many kilograms of stuff there was in Europa. But you also got to know, how big is Europa? By the 1840s, they knew that they could, Europa is just a tiny dot. You could guess the size if you really thought you could see, measure from one side of Europa to another. It's a dicey thing to do, but you can also just time how long does it take for Europa to completely disappear when it goes behind Jupiter, and how long does it take to exit from the shadow of Jupiter. By timing eclipses, by timing Europa or the other moons going behind Jupiter, you can actually calculate the size of Europa. In order to know the brightness of Europa, you've also got to know the size. I can measure how bright it is in a telescope and compare it to a standard star, but am I looking at something that's really tiny and shiny, or something that's very dark but big? Well, from these measurements of the size, we can work out that Europa was kind of tiny and kind of bright, right? So you must have, by the 1840s, the 1850s, they knew the masses, they knew the sizes, they knew the brightnesses. Somebody must have come to the conclusion that they were made of mostly ice or a mixture of rock and ice. So I go to our Vatican library again, and I look on the shelf and I find a couple of popular astronomy books from the 19th century. Simon Newcomb, one of the, he was the Carl Sagan of his day, wrote this book. An Englishman by Chambers wrote a book, each of them describing the icy moons. Simon Newcomb, the Carl Sagan of his day, writes, the light of these satellites varies to an extent which it's difficult to account for except by supposing very violent changes going on in their surfaces. What? Bunch of amateur astronomers. How many in this audience have ever seen the moons of Jupiter through their telescope? Probably a lot of you have. Raise your hand if you've ever seen the moons of Jupiter. Everybody. How many of you have ever noticed the brightnesses of the moons of Jupiter changing radically and violently? Like, I never have. Nobody I know is there. But in the great book of the 19th century, that's what it says. You'll find this in Webb's, famous 19th century book for amateur observers. The weird thing is, what you don't find in Newcomb, he will list the brightnesses, he will list the masses, he will list the radiuses. He never bothers to calculate a density. He never bothers to try to guess what they're made of. None of the books in the 19th century do this until the end of the century, except that Englishman, Chambers, who I talked about. Nobody calculates the density from the masses and the volumes except George Chambers. And there's his calculation. There are his masses. There are his diameters. From the diameter, the volume, 4/3 pi r cubed. Anybody who's gone to high school, knows that one. And there's the densities. You probably can't see that, so let me blow it up. He calculates over the 4 moons of Jupiter, Io has a density of 1/10 the density of water, Europa of 1.17 the density of water, Ganymede 0.39 the density of water, Callisto 0.2. Wait. He has all of these moons not just being less dense than rock, but less dense than water, like 2/10 of the density of water. Can you think of anything in nature that has that density? I mean, gases are way, way less dense than water. Ice is a little bit less dense than water, but only 20% the density of water? Only balsa wood, maybe. He never goes on to speculate what material might be there to make up these moons. But these numbers are totally wacko wrong. And then it makes me wonder, his values for the mass can't be all that bad. His values for the radius can't be all that bad. If I divide his mass by his volume, I come up with numbers that are actually not all that bad compared to what we have today, but they're completely different from the numbers he actually publishes. And that's not even a systematic error. Sometimes his numbers are off by a factor of 10, other times they're off by a factor of 4. What's going on? To this day, I haven't figured out where the heck he got those numbers from, but boy, are they weird. He's the only one to make the calculation. He makes the calculation totally wrong, and he never goes back to say, does this make sense? He just happily publishes the numbers in his book. And that's the state of affairs until the end of the 19th century. And Edward Pickering at the Harvard College Observatory, I was once a postdoc living in that building, publishes his numbers. And these are the densities based on two different ideas of how big they are. Those numbers are not all that wrong. In the albedos, he comes up with, they're fairly bright. They're not as bright as we actually know they are, but he realizes that they're, brighter than the moon. He writes, it has been thought by many astronomers that the lights of the satellites of Jupiter was variable, but that's not sustained by the present measurements. How did he measure the brightness of the moons of Jupiter? Everybody else took their telescope, they looked at Jupiter, they saw the moon, they saw how bright it was. They then went to a standard star and they said, okay, it's about as bright as this, but not as bright as that. What Pickering did was he had a little gizmo in his telescope that would darken down the moon by Jupiter until it was as bright as the moon he was looking at. And when he did that, the moons had a constant brightness. Can you see what he did wrong? Can you see what everybody else did wrong, I should say? Everybody else was looking at Europa when it was next to Jupiter, which is so bright that it made their eye make everything dimmer. And then when Europa was far away from Jupiter, suddenly Europa looked bright enough again. And they had come up with crazy ideas that, there was violent things going on the surface, or maybe Europa is spinning so fast that it's really flat and tumbling. So sometimes I'm seeing it face on and sometimes I'm seeing it edge on, and that could explain the great changes in the brightness. Pickering finally says, I don't see any great changes in the brightness. Then he talks about the densities. The densities are very small for solid bodies, much lower than the density even of the moon. Such figures would imply that the bodies are either enveloped in clouds, which I don't think is likely, or they are composed of dense swarms of meteorites. Their density and their brightness is what we would expect if they were composed of loose heaps of white sand. And why does he think they're made of white sand? Because only that, I'm going to come back here. How else could you have rigid bodies make those plate-like shapes that everybody talked about before? The reason people thought the bodies were shaped like plates was to explain the changes in the brightness that he says aren't true. And then he says, the reason I think they have to be made out of sand is because only sand could make a flat disk that would give you that plate-like shape. So close, so utterly wrong. The first guy who finally says they're made of ice was Jeffreys in 1923. And the reason he thinks they're ice is because of their density and their brightness, which is the same reason I think they're made of ice, and how that I knew then. He then concluded that Jupiter and Saturn have the same density, so Jupiter and Saturn must be made of ice. Oh, well. So I said I wasn't going to be making fun of other people. Where does my work come into this? This is the last page of my thesis. Given the temperatures of the interiors, especially the silicate layers, you get this rock that was falling through the water percolating up through the rock. I say, there may be simple organic chemistry in the water, either methane in the ice or carbon in the rocks. However, I say, we stopped short of postulating life. I love the royal we that I'm writing about. I'm 22 years old. We stop short of postulating life and leave that to others more experienced than ourselves in such speculations. I was thinking, of course, of Carl Sagan. I was making fun of Carl Sagan. Carl Sagan wanted to find life everywhere. The very first time I presented this work at a scientific meeting, the chair of the session was Carl Sagan. So I go up to Carl Sagan and I say, hey, I got this great idea. Life in the oceans of Europa. And he goes, Guy, life in the oceans of Europa is impossible because they're under the ice crust. It's going to be dark as midnight there. The light can't get through that ice, and life requires energy like sunlight. And I'm going, I was so close. Well, it's a good thing I didn't say that in the talk that I was about to give, because then people would laugh at me. About 4 years later, we discover that there is life in the deepest part of Earth's oceans. It doesn't depend on sunlight. It depends on black smokers. It depends on the energy coming out of lava at the bottom of the. And not only that, but somebody else, not me, writes a whole paper about the habitability of Europa. The second author is a grad student of Carl Sagan's. And these guys deserve to get it right because they actually did the science. I was just speculating based on science fiction. What's my lesson to all of this? Science makes mistakes, which is why it's a lousy basis for any religion. Science gets it wrong because it's supposed to get it wrong because it learns by correcting mistakes. If you don't make mistakes, you'll never learn anything. And of course, sometimes the mistakes aren't even in your data, but in your imagination. I end with one last picture. Here is my beautiful vision of Europa. A rocky core, maybe even an iron core in the center of it, an ice crust a few tens of kilometers thick, and an ocean underneath it. Imagine, if you will, if you're an intelligent tuna swimming in this universe. You're going to see a universe where the rock is completely covered with the water and where there is a crystalline sphere above you. And maybe someday an impact occurs and you can look out and see that the universe is full of stars. Thanks a whole lot. If you want to know more about the Vatican Observatory, you can go to our website. And from here, I'm happy to take questions.
Do we have any questions here?
Wasn't one scientist, astronomer, who had speculated that the stars were actually suns burned to death by the Vatican?
Post hoc ergo propter hoc. You're thinking of Giordano Bruno. Look up Bruno in Wikipedia. Don't take my word for it. The reason he was burned at the stake was because he was a nasty piece of business who was run out of every country in Europe. And yes, he thought that every star was a sun, but he wasn't the first one to do that. Nicholas of Cusa said that 200 years earlier when he was a cardinal. So yes, he said that, but he said it not for any scientific reason, but because of this mystical view of the universe. The core essential part of his mystical view of the universe was that he's smarter than everyone else, and he wanted to make sure that everybody knew he was smarter than everyone else. And he was, treated tolerably for about 30 years before people finally got fed up with him. He was basically, no, it's bad to burn people at the stake. I'm not in favor of that. But he was not burned at the stake for his, for his science. He was not a scientist. He's not somebody who I'd like to put up there as a hero of science. I've also could go on for hours about Galileo, who was a good Catholic. His daughters were nuns. He never married their mom. He was an Italian Catholic, but he was a good Catholic.
Yeah, Brother Guy, I've had a
Yeah.
chance to the Vatican website. It's very nice. And in one of your videos, you were talking about the glass plates, photographic plates that have been. And you said that at some point you're actually going to make them public so that people can see them and research. When will those plates be available for the public?
I have to give you the answer that all the techies in your audience will laugh at real soon now.
Very good.
The scanning is complete. We were working with a repository in Germany that was trying to assemble all of these, because it's not enough that you've got 10,000 plates. You've got to have some kind of index so that you can figure out which is the plate that I want. Where do I go to find the exact plate? What were the circumstances? And all of these things have to be put into a database. And it turns out to be harder than you think it would be. But the scanning is complete. And if you've got a question and you really want to know, do you have plates from this particular part of the sky? You can just write to us and we will dig through and find them and then, show you the scans. It can be sort of done on an ad hoc basis. But sadly, we're not at the point where you can just go online and, type in a number and find them. That's our goal. That's our dream. And real soon now.
How old are the oldest photographic plates?
The oldest ones we have go back to the Carte du Ciel program, 1891. And this was a program where the 18 major national observatories were each given a piece of the sky to photograph so that you would have one giant photograph of the entire sky. If that sounds familiar, that's what the Vera Rubin telescope will do 3 times a week once it's up and running, which is in about a year. For the Carte du Ciel and the technology of 1891, it took about 40 years to get one complete set of photographs made. The Vatican was involved partly to show the world that, hey, the Vatican is not, in the business of burning people at the stake because they're scientists. We invented science. But also to show the world that the Vatican's national observatory was as good as any other nation's national observatory because we were a nation different from Italy, which the Italians didn't particularly like. Conspicuous by its absence in this program was the United States. There was no photography of the sky for the Carte du Ciel done by any observatory in America. Instead, the Americans decided to put all of their money and effort into building the 100-inch telescope, which, of course, Hubble used to work out the expansion of the universe. And some people say that the Carte du Ciel program sucked up so many resources of European scientists that it allowed the Americans to get ahead of Europe for the first time.
Okay, do we have any other questions? Anybody online have some questions?
If you're online, you can go and unmute yourself and ask the questions that you'd like answered. Go ahead.
We'll still have some time in a minute here. Thinking along as we're listening to you today, we have a lot of theories that are new and many different ones just recently, because we're looking out further at new concepts. We thought we had everything that we could see. See is only 5%. The regular matter. There's now a dark matter, and there's even dark energy, which
and that's what we know now. Ask me in 100 years.
That was my comment. In another 50 years, will we have another theory like this, or a meeting where we can discover all those weird things that we were thinking of.
And
That
that's the real message of my talk. Don't think that the latest and newest is the best that we'll ever get. Don't think that it's going to be correct. Probably 50% of it is going to be wrong. We just don't know which 50% yet. But that's the way that science works. Hey, when I was at MIT, I was in the sailing team. I loved sailboats. The Charles River is where we sailed, and the Charles River back then was really polluted and nasty. So I made sure all the time I was in the dinghy sailing in the Charles River, I never once capsized. But I also never once won the race. And to be able to make progress, you have to not be afraid of capsizing. You have to not be afraid of coming up with crazy, wild ideas and letting them be put to the test and letting people say, you know what, that doesn't work and here's why. And in the process, we've learned something new. That's what science is. It's not being afraid of making mistakes. That's why it's a very different kind of operation from religion. Science is human theories so we can understand them, but it's trying to explain a universe that will always be a little more complicated. We'll never have the complete truth. Religion is not human theories. It's encountering something that we know we'll never understand completely. And that's why you also can't be so dogmatic, not to say that things aren't true in religion, but to say that I've understood them completely. There is where the mistake comes in religion. To say that I've got because what is science but a love affair with the universe? What is religion? That we hope it's a love affair with God. And many of the married people out there, if you think your spouse is somebody that you've got completely solved and understood, and you know everything there is to know about them, boy, are you in trouble. But also, boy, are you missing out on what all the fun is, which is to learn the new things, to find out that everything I thought I knew was right, but there's more to it than I thought. And that's why we never tire of looking at the sky.
That's very true for this group. We enjoy going out to our observatory and
Yep.
find new things, looking at this and what people have found in the past.
Mm-hmm.
See the stuff observing and
Right. And I hope you all have copies of Turn Left at Orion.
okay.
Very good.
Any other questions here? I hear none on the line. I do not see anything additional in the chat box.
Thanks a whole lot for having me here and letting you listening to my stories. And I hope you got a chuckle or two out of them.
Thank you for joining us.
Thank you very much. I learned a lot here.
Okay. Take care. Keep looking up.
And I think we have opportunities to think about learning a lot more in the future. And maybe even correcting a little bit of what we've learned so far.
That's where the fun is.
Yes, it is. Well, thank you very much.
I'll be off to dinner. Have a great meeting.
Okay.
Thank you again, brother guy.
Thank you. They keep looking at it.
So,
Yeah.
Okay. Sure. Okay, here we go. Okay, just want to move on to review what we're doing in our outreach programs coming up, because we've had a few changes and additions to that since we last met here. Of course, our first Miami Zoo public observing session is going to be March 16th, coming up in just a little more than a month, and that will continue through November. March 20th, we'll have another one of Moline Library's Project New Generation sessions, and we'll concentrate on preparing for viewing the eclipse at that, because we'll have another one at the Rock Island Library, very similar. And then April 8th is our big day for the eclipse. We will be at the Moline Public Library, similar to the observing session we had back in 2017 for the previous eclipse. John Middle School is asked for 3 sessions during the school year, still determining when the best time will be for that. We have had requests from the Giant Goose campsite east of the Quad Cities for their youth day. Again, we've done that several times in the past. Eldridge Library would like us to come back for more stars and s'mores. And we get observing good snacks out there on June 24th. Illinois Campground again. It's one of their most popular programs at the campground, so we will be participating in that again this year. We've been asked about the Bishop Hill again, do not have any details, so that's still tentative. The Sills Library is having a big centennial observing session, and I believe we have now fixed that just this week at July 11th. I think this. Again, Riverdale Schools would like to have us out again, so that will be happening in September. Okay, and we've had just recent inquiry from Putnam Museum. They would like to have us back again sometime this summer, but we don't have a schedule or they don't have a specific plan for that program yet. Earlier, we had been asked by Butterworth Center here again to participate in their open house program, which usually is in September. In addition to our public programs, we have future meetings coming up here. Next month, March 11th, we'll have a business meeting and smorgasbord talks. If you have something you'd like to talk about, share with the rest of the group. See Dino, he will be coordinating the list of speakers for the smorgasbord talks.
We've got one already. We'd like to have a few more.
We're often starting already. We know we're going to have a program that night. On April 8th, which of course is the evening after the eclipse, where we will be at Moline Library. That evening, we will have a program here, Solar Flares, Neptune's Clouds and Chemistry by Robert Gregory. A month after that, in May, we will have a program by David Weinrich called Keep Looking Up, One Sky, One World. Later in the summer, we'll have our traditional picnic on the weekend closest to the Perseid meteor shower, and our annual banquet is scheduled for October 11th, 12th. Here. We have some interesting meetings coming up. Remember a few years ago, we hosted a national North Central region. This year, May 17th and 18th, they will be at Pear, Wisconsin, which is near Green Bay. And they have some information at the website, or you can just look in the national newsletter where there's some information about that. Our next region to the west of us, the Mid-States region, they have their conference scheduled June 7th through 9th at a state park near Omaha. Do not have any details about that yet. In July 17th through 20th, the Astronomical League will have the big conference. This year is at Overland Park in Kansas, which is near Kansas City. And I looked to see what it was all about, and on astroleague.org, it says information is coming soon. So check in a little later to actually see what they're doing and what the program will be on July 17th through 20th. I did notice we do have a possible conflict with a rain date of a program during that time. So I don't know how many people from here might go to that. I don't know. Has anybody here planned yet to go to the natural in Wisconsin, May 17th through 18th? Anybody raise your hand if you're thinking about it?
Ray and Jan are signed up.
Okay, maybe 2 to 4 of us may show up there. Yes, we want to move on, quickly to some, member observations. I know, Al sent out a interesting picture of a really interesting sunspot the other day, and I assume you probably brought that tonight. If you can share, if I turn on the share.
See here. I don't know if this is the exact, I think I sent several pictures out on this, but let me, I gotta share it. Unless you got it. Okay, hang on. No, it's a thing. I got it.
Well, while you're looking at, I will say that the same day that you did that, I took one of the scopes that has been recently donated to the club, the Celestron Sky Prodigy, which was donated with a solar filter. I was able to set it out on my deck that afternoon, had a good view of the sun, which I haven't had for a couple of weeks. And I got a view looking very much like the view you have here. Unfortunately, I was unable to get a good focused picture with using my cell phone on the eyepiece there.
You need a cell phone adapter.
I had to go to a meeting later that day, didn't have time to dig all that out and set it up. That'll be the project for the next Sunday. Hope to get everything ready sometime before April 8th. Okay.
Yeah, this sunspot, you can, actually, there's a bunch of sunspots there. If I could figure out how to zoom and see them.
Looks like a nice collection of them. They're just left of the center. I did notice in some online news, I think it was the next day, it was reported that there was a significant solar flare coming from the sun. I didn't see yet
There was a picture.
mentioned with this specific sunspot or whatnot. They generally are somewhat related.
The picture that I saw, you could actually see it popping from the surface. They had an angle on it. It was really cool. Was that in the newspaper? No, it was on Facebook. I know it was on.
Now it's reading.
The zooming one, I didn't want it to. I couldn't get it to zoom in.
Now it is.
Now it is. Anyway, that, this cluster of sunspots right here, to kind of put that in perspective, that is many times larger than Earth. The breadth of the sun here is 109 Earth diameters. So you can imagine that large cluster right there is probably 1/10 the size of the sun. So that's on the order of 10 times bigger than Earth.
So it's really even bigger than a Jupiter size.
Yeah, that's
sunspot
Jupiter
there.
size object right
More
there.
like 10 times your.
Yep. Oh, I had one here too. I don't want to do stuff you don't want me to do. I got a picture here of the sun using donation to, well, this is looking through your telescope in hydrogen alpha. And this is actually two pictures, one that had a short time exposure to get the granularity of the surface of the sun, and then another one I superimposed in behind it to show the prominences around the side that's more exposed. Actually, when you're looking at it through the eyepiece, it's a lot more spectacular than what I've been able to do with the camera. It's really amazing. And that's something that we could use at the Moline Public Library. Hopefully it's clear.
Yeah, it should be very interesting. Well, I think it will be other places too, because we will be doing at least one solar observing program when we go to the youth campground.
And I've got some other pictures here. The one that a lot of these here are just snapshots of Messier objects that are visible right now, but the one that my favorite is this one right here. That's the Orion Nebula, obviously. And I can zoom that one here. Yes, there's some product things you can see. And right down here in the center, you can see a multiple star configuration called the trapezium. It's a trapezoid shaped cluster of 4 really bright stars right in the center of it. And then it's surrounded by lots of gas and dust. This is M42 right here, and this is M43 up here. So when you get that framed right, you can actually bag 2 SAA optics in one eyepiece view.
Wow, that's pretty good.
That's pretty cool. If you're looking at it with the eyepiece, with your eye, you don't see these colors though. The camera can grab the colors. Anyway.
Single shot.
Yeah, well, actually, this is 2 shots. And let me see, yeah, right here, see this here? So, now, that's what happens if you get the dust and clouds out here, then the interior where those where the trapezium stars are, there is overexposed. So I created another exposure that was less exposed, so you can see the trapezium and I see the opposite. So I cheated. This is a cheat. Overjob. But you can see that, you know, when you're looking at it with your eye, you can see it, but the camera can't get both. The dynamic brightness range isn't as good as your eye. Your eye is an amazing camera, really. We had some pictures. Byron had some pictures on Byron's online here.
His last few pictures have been something.
I'll show you these. I don't know if Byron is able to found that.
Oh, that's nice.
This is NGC 2264. Byron, if you're there, you want to talk about it. I think they call this the cone nebula over here. See that? Looks like a cone.
I don't see Brian on the list
Yeah.
right now, so he means.
Yeah, but that's an amazing shot right there. That's a very wide field shot, and I would say probably use a Takahashi probably for that because I don't see the spikes that you have with it.
And his new camera as well.
New camera, yeah. Let's see, the other one that,
One they did yesterday was the one that had like a zillion different things.
is that this one?
Remember?
Yeah.
SH,
Oh, that's the day.
SH2-274.
Well, I think it was one of these, the one that kind of sent me.
That looks like a planetary nebula.
I'm not sure what this,
This is
I'm
Monday.
not sure what this is.
Saturday.
Okay, hang on, I got another one here.
That's I'll spell it. MEDUSA Nebula.
Medusa Nebula.
Yeah, he's doing that tonight.
Oh, okay, that's where he's at. Yeah, tonight the conditions are good.
Yeah, he's been imaging the last few nights when we've had some clear skies because the moon is in a crescent form right now, but it'll be in a few days be quarter phase and then the moon will be blocking him out.
And then the other one, maybe this is the one you're talking about, NGC 2238. What's the proper name for this one, Mike?
Rosette.
Yeah, this Rosette Nebula.
That one before that is the Cone Nebula.
Yeah. I think there's a couple of things in that picture, but the thing that's really cool about this, you can see all these little smattering of like, what would you call it?
Dust clouds.
Dust clouds that are like streamers. That's really amazing. Yeah, Rosette Nebula. what that's called. So these are amazing pictures. I don't know, I don't have the statistics on how many hours of photons he gathered for that picture, but I'm sure it's many hours. And then, yeah, going back to, here's the first one here. There's the Cone Nebula over here.
Right. Yeah.
That's a different stuff that he has.
Yeah,
He
and
said he said that wasn't the best of conditions on Saturday night. It was okay, but the conditions could have been better.
there's an object down here. I've seen this before. I don't remember what it's called. Do you remember, Mike?
I don't.
He has a whole list on the thing we put on it, where we've gone into.
Yeah.
It's 7 or 8 things.
And then there's some dark nebulas over here too.
Mm-hmm.
So, yeah, you could study this image here for probably hours and not.
Byron, he's really hooked on it, let me tell you.
Yeah. So, not to get hung up on religion, but I mean, you've got to believe that there's life out there somewhere. There's a lot.
Yeah, I'm glad you pointed out the cone. I didn't really notice that, but yeah, when you blow it up, you can see it when like the Hubble takes a picture of it and you really see it well, but you can make it out there. That's pretty cool.
Yeah. And I guess what is that? That's dust and gases that are being pushed away by light pressure from these stars over here, I'm guessing.
Yeah, I'm not sure.
Or wind. Let's see what else I got. I got some other ones here. I got some from Mike Mack. Some of you probably remember Mike Mack. He's a former member. He lives in Madison now. He's doing great things here too. This is M1. Which kind of looks like a brain. Actually, this is this is a star that went supernova about 1,000 years ago. And it's expanded out now into something. I'm not sure the dimensions of it now, but it's expanding. Eventually it'll dissipate.
Did you ever watch that episode of Star Trek where there was a huge amoeba?
Yeah,
It's kind of.
that's kind of what it looks like too. This is the proper name of it's Messier #1, but it's the Crab Nebula. Is the proper name of it. And then this is Mike's picture of the Orion Nebula. This is taken with his setup. His might be a little better than mine. His camera is able to gather everything without being blown out like mine was. So I got to figure that out. But anyway, this is one of the, if you want to get into astrophotography, this is the one to start with right here. This is anybody can get a decent picture of this with a little patience and the right equipment. It's you know you can do a 30-second exposure and get this one well if you have a telescope that can track. You don't have, this doesn't take hours of light to get a picture like this. Let's see what else I got. Oh, I got another one here I got to show you. This is one of the most incredible pictures. This picture is from Mark Joe. He's from the Minnesota Astronomical Society, and my involvement with the region it puts me in contact with a lot of people. And when I saw this picture, I had to have a copy of it. He sent it to me and said we could use it. This is a dark nebula.
Yeah, those are hard to get.
And I forget the actual numbers, but this was taken by him from his remote observatory in the hill country of Texas. He lives in Minnesota, and he has his own observatory in Texas. He takes pictures from it. And it's a portal 1 sky, so it's very dark. This is 19.75 hours of light accumulation into one picture. And he told me all the stuff he does, but I'm not even smart enough to understand the techniques that he uses. That's the most incredible thing, you know, for dark nebulous. It looks like cigarette smoke or something.
It does.
Yeah.
That was started.
Yeah, he was examining, and to hear about how, what it is.
Yeah, it's not about.
Yeah.
The news.
Okay.
Oh, yeah.
So we need to move on to the announcements.
We'll get a deeper into it and see it.
See, there's a
Look at
galaxy,
that.
there's a galaxy right there.
And look, it's actually sharp.
That's the resolution in this picture is really good. I wouldn't be able to have tracking good enough to go 19.75 hours. And you couldn't do that in one night either. It had to be over several.
Yeah, you don't have that long.
Yeah, there's galaxies out there. There's all kinds of stuff. It's like kind of like the Hubble image.
Like that picture comparison of the pillars of creation between the Hubble and the James Webb with all the additional galaxies in the background. And we did the same picture with the James Webb.
I think those are all the ones the good ones I've got. I've got.
Okay, we have a few announcements then to go through here tonight. Should have okay, here we go on to the next. Want to talk a bit about the solar eclipse glasses. We have them in. Mike has them here. We distributed some. We bought a large order, got a price break because we combined our order with QCAS. And what we have are some here we'd like to have enough to have a sizable number on hand on April 8th. I will be talking with the Moline Libraries about that. They have, I believe, close to 1,500 people there in 2017 for the eclipse, and expecting not quite that many this time. But and not everybody would need solar eclipse glasses too. I hope to have quite a few available on the day, but until that time, we will be making them available at all of our public programs. I will be distributing a few. I have some neighbors and some other organizations. Some of you are already part of things like the hiking club here, and we'll give a few out at those meetings. And I know a few of you have asked for additional quantity, so we'd like to make a few available, maybe quantities up to 30 or 40 or so. If you want to distribute some to other groups or your friends, your neighbors, family, or whatever. See Mike and let him know how many you want. And once we get to that point where we have just enough to make sure we'll be in good shape on April 8th, we'll have them available until that time.
On Hy-Vee, when I was shopping at Hy-Vee, they had a little cardboard stand that was featuring their solar glasses, and they were selling them for $5 a piece.
$4.99. I took a picture.
Oh, that's a big difference. With our price break, we got, I think,
Somebody, you know,
piece that we paid for from Astronomical League. And so far, that is the cheapest price I have seen anywhere for the certified glasses. There's some cheaper ones out there, but they do not say they're ISO certified.
I got a text from one of the stepdaughter, went to his grandmother. They live in Fairfield Bay, Arkansas, which is in the path of totality. And Fairfield Bay, I don't know what the population is, it's maybe 8,000 to 10,000, if that much. You know, they're expecting 50,000.
Closer to me.
It's gonna be.
I a few people, Texas seems to be the popular place this year, along with some in Arkansas, spot for Carbondale, and so Indianapolis and Cleveland, and you know, people in Cleveland. Usually cloudy there. Okay. Okay, there are a few members who have not renewed yet. If you haven't, I urge you to renew as soon as possible. If you do not renew before we turn in this year's list to the Astronomical League, you probably will not be on their newsletter list anymore. Yes, I wanted to, this morning, picking up the newspaper, found Al's article on winter football, Super Bowl in the sky. Very timely to have that today.
Who won?
Like serious.
Kansas.
It looks like this game was played between several different constellations up there. It's hard to tell who won. They kind of went around in a circle, or football is up there.
Oregon's on top.
Oregon, it didn't come up on the top as the picture was arranged here.
I also want to just comment that, you know, I sent that, to Paul, our newsletter editor here. And, Paul, you reworked it and made it flow a lot better. So, I came up with content that you made it into what you see there in the newspaper. So it's kind of a joint effort.
Teamwork.
And it's on our website now.
Yeah.
Yeah, in our newsletter too.
If anybody wants to write, you know, articles like that.
If you have something to say and get it down on
Get it out.
paper, Paul did similar for the one I wrote. It's been a while back now. But Paul did a good job of making it presentable to the newspapers, and obviously they liked it and printed it at the very. I don't know if they printed it because the Super Bowl was yesterday or because our meeting was tonight, but it worked either way.
Super Bowl might have a lot to do with it.
Okay. Since our last meeting, we have a new member, Donna Holden. And I think I saw the name on the member list here.
I'm here.
Okay, well, welcome you to the Popular Astronomy Club. Hope you
Well,
enjoy.
thank you. I'm delighted.
Good to have you with us.
Okay.
And we have a man that's here for the first time. Eric, you want to introduce yourself?
Eric?
Sure. My name is Eric Bakken, in the area, just retired, and just thought I would join and participate, since I've been out to the zoo since last year. So, yeah, looking forward to learning some good stuff. This fantastic presentation. Thank you.
Well, thank you. Good to have you with us, Eric. Okay, let's see. Do we have any other announcements, comments, questions, concerns for tonight? If not, that's all we will have for tonight. Thank you, everybody, for coming. Thank you to those who joined online. Remember, our next meeting will be March 11th, and that's as the weather gets better in March, we'll be kicking off the season that we thought of public programs and other programs here and conventions coming up. So thank you all, and keep looking up.
Thank you, Dan. I'm so happy.